Alright, hey guys, this is going to be a quick little video showing how to graph problem number 54 on the quiz. So how do we do this problem? Well, first thing to do is we're going to be sketching this graph, okay? And we need to list the three things that are asked of us, which are the x-intercepts and their multiplicities, y-intercepts, and the end behavior. Okay, so as always, you'll have to excuse my poor drawings. Okay, so let's start with the end behavior. What is the end behavior of this function? Okay, so for end behavior, recall that the end behavior of a polynomial is dictated by its leading term. And so what that means is that when you have the polynomial in standard form, you're going to put the power of x that's largest in front, right? So we always go from largest power of x to smallest power of x. What we have is f of x is equal to x plus 5 squared, x minus 5, and then x plus 1 squared. Okay, hopefully you can see that once you expand this term, the largest power of x you'll have is an x squared term. That's the largest power that this expansion is going to produce. This term, since it's linear, there's only a 1 here. The largest power that this one is going to produce is just an x. And the largest power that this x plus 1 squared is going to produce is also an x squared, because once you distribute this or FOIL it, the largest power of x in that expansion is going to be x squared. And so by looking at that, eventually we're going to multiply these three things together. And so the largest power of x is going to be x to the fifth, okay, because you're going to multiply x squared times x, which will give you x cubed. And then you're going to multiply that x cubed times x squared, and you're going to end up with x to the fifth. And so if that seems like magic to you, well, I'll try to go quickly and expand this so that you can see that the largest power of this polynomial is in fact x to the fifth. And so, well, if we expand this, we have x plus 5 times x plus 5. Doing the rainbow method, the FOIL method, expansion, whatever you want to call it, you're going to get x squared plus 10x plus 25. Okay, I'm just going to bring down the x minus 5 here. X plus 1 squared is going to give us x squared plus 2x plus 1. And now when we multiply this trinomial times this binomial, we're going to get x cubed plus 10x squared plus 25x, and then minus 5x squared minus 50x minus 125. And so that's going to give us x cubed plus 5x squared minus 50x minus 100. Okay, and then we still have the x squared plus 2x plus 1. And so hopefully from here you can see that when we expand these terms over here, the largest power of x we're going to get is from the largest power of x in this polynomial and the largest power of x in this polynomial, which is going to be x to the fifth. Everything else that we get when we expand this is going to be a smaller power than 5. So the leading term of our polynomial is in fact x to the fifth, like we hypothesized up here, because this one will give us an x squared, this gives us an x, and this gives us an x squared. And so eventually we'll multiply all these out together, and we'll end up with x to the fifth as the leading term. And because all of these have 1 as a coefficient, it's just 1x to the fifth, and so it's a positive. And so what do we need to do? Well, once we know this is our leading term, we know that a polynomial behaves in the end behavior as the odd functions do. So because this is an odd functioned polynomial, it's going to have the same end behavior as the function x cubed. And so what does that mean? Well, that means as x approaches negative infinity, y is going to approach negative infinity, and as x approaches positive infinity, y is going to approach positive infinity. And how do I know that? Well, because the function x cubed kind of looks like a snake or a slalom, kind of looks something like that. And you can see that as we go to negative x's over here, the arrow is going down to the negative y's. And over here, as we're going to the positive x's on the right, the arrow is going to the positive y's. And that's essentially what this thing right here says. Excuse the terrible arrow, right? So as x goes to the negatives, y goes to the negatives. As x goes to the positive, y goes to the positives. And so this is our end behavior right here. So we can grab that piece. All right, make it smaller so it fits on our answer sheet. Okay, so there's our end behavior. Cool. So now we need to find the x-intercepts and their multiplicities. And so to do that, I'm just going to grab the function from here so I don't have to write it again. That is not what I wanted. Let's try that again. Okay, it's not going to let me do it, so that's okay. We'll just write it. We have f of x is equal to x plus 5 squared times x minus 5 and x plus 1 squared, I believe. Yep. Okay. And so now we're looking for x-intercepts, right? And so to find x-intercepts, what do we need to do? The same thing we always do. We set y equal to 0. And remember that f of x is another name for y, so we just set that equal to 0, and we solve for x. Okay, and so since we have three things being multiplied here, we can use the zero product property, which tells us that if one of these things evaluates to 0, everything is going to go to 0, right? Because 0 times any number is always 0. So all we need to do is look inside the binomial and set each of these to 0 so we can figure out what would make it 0 that's going to make everything else 0. So you may have multiple answers here, okay? And so a little bit of solving a linear equation. We subtract 1 from both sides. We get x is equal to -1. Here we add 5 to both sides. We get x is equal to 5, and we subtract 5 from both sides here. And we get x is equal to -5. And now because technically, right, this isn't just x plus 5, but it's x plus 5 times x plus 5, that means we have this solution twice, right? So this x-intercept, -5, 0, has multiplicity 2, because there's 2 of them, right? It's -5 and -5 again. Because this one is just the first power, we only have this solution once, so you would say this x-intercept is 5, 0, multiplicity, I'm just going to write mult here, multiplicity 1, and then just like the -5, this -1 is also squared, so this x-intercept is going to be -1, 0, multiplicity 2, okay? So let's grab that, move that up here. There are the x-intercepts. And now we need to find the y-intercepts. Okay. How do we find the y-intercepts? Well, the same way we always do, by setting x equal to 0, right? We want to find the y-intercept. So we set x equal to 0. So we're saying f of 0, right, x is equal to 0, happens when you set all the x's equal to 0, and we want to figure out what is y going to be. Oh, sorry, this should be 0. Okay, 0 plus 5 is 5, and 5 squared is 25, right? 0 minus 5 is -5, So we have times -5. 1 plus 0 is 1. Squared is 1. And so we have 25 times -5, which is -125, times 1, which is -125. So our y-intercept is, when x is equal to 0, y is equal to -125. Okay? So let's go ahead and copy that. Paste that in our solutions. Okay, and now all we have to do is graph the function. And we have everything that we need to sketch it. Okay, so we know the end behavior. So we know that when x becomes negative, right, that's this part right here. Grab my pen. So when x is negative, y is going to be negative. So we know, well, when x is negative, that's over here. Y is going to be negative. So we know our arrow is going to end up pointing somewhere down here. We know when x is positive, y is positive. And so that tells us, because the positive x's are here and the positive y's are here, that means as we head this way, we're also going to be going up. So we know our arrow of our function is going to end up somewhere up there. We know our x-intercepts. We have -5, so -1, 2, 3, 4, 5, right? And we have a +5 as an x-intercept, 1, 2, 3, 4, 5. And we have -1. Okay, so there are x-intercepts. And then our y-intercept is 0, -125, so I'm not going to drive 125 of these lines. I'm just going to put -125 here, and so there is our point. And so what I'll do is do these in a different color like I should have done from the beginning. So this is -1, 0. This is -5, 0. This is 5, 0, and this is 0, -125. So now we know our picture, right, is going to end up in the corners and start in this corner. And so we start with our arrow here. We just start drawing. And then we get to our x-intercept. Okay, because this is the intercept -5, 0. Because its multiplicity is 2, it's even. That means instead of going through the x-axis like this, we're going to touch it and come back. If the multiplicity is even, you touch the x-intercept, like you touch the x-axis, and then you just go back down. You don't actually continue crossing through it. So we're going to touch it and then come back down. And then we know we have to touch the x-axis again, right? Because we have another x-intercept here. And so we're going to have to start heading up at some point. We get to it and we see, okay, this is -1, which also has multiplicity 2. So this one's even as well. And so we're going to touch it and come back down. And that should make sense because we still haven't gone through our y-intercept. So let's go ahead and head all the way down to our y-intercept. And then we see, okay, well, we have an x-intercept, so we're going to need to start coming back up. And then this is +5, 0, right? And so this multiplicity is 1, which is an odd number. And because the multiplicity is odd, that means now we can actually cut through the axis. So when the multiplicity is even, you touch the point and you come back. When it's odd, you go straight through it. Okay, and so now we know, look, we don't have any x-intercepts to touch, to go through. So there's no reason for us to come back down. We can just head off until the end of our arrow here. And that is a sketch of the function. So this is -5, 0. This is -1, 0. This is 5, 0. And this is the sketch of our graph. So to be able to graph this, to get full points on an exam, I want to see your logic for the end behavior, our work that we did for the x-intercepts and their multiplicities, finding the y-intercept by plugging in 0 for x, show that work. And then basically what you do is you plot the end behavior with the arrows, you plot your x and y intercepts, and then use the logic that we came up with on their multiplicities to whether it touches or goes through, and you should come up with a sketch of the graph. So if you have any questions, go ahead and ask me in the Discord, and I'll see you guys in the next one.